All right, we've come out here to rural Missouri, southeastern Missouri, to check out the total solar eclipse. And I can't see anything through these glasses except for the sun up there. So I have no idea what I'm filming right now. Okay, we're getting set up for the eclipse. We've got the tiny radio telescope, which is wiggling around in the wind like crazy. We've got it scientifically duct taped to a tripod. Not the most stable observation platform, so I don't think we're going to be doing any groundbreaking science with it. Do you mind being on my YouTube channel?
No, I don't.
What,
it's awesome.
What's your name?
Jimmy.
And,
how you doing?
And what's with the hat, Jimmy?
We're gonna lose the sun today. There's aliens.
well, we're going to check on that. So I brought this little dish down at the absolute last minute as we were going out the door on the way to see the eclipse. I just threw it in the car, threw a couple 9-volt batteries on there to power the L&D, and then we've got it hooked up through a software-defined radio to the laptop down there, running that off one of my little power banks. I've also got my old camera with the really nice zoom lens on it, and one of our friends actually had a solar filter for the camera. I was just going to tape a spare pair of Eclipse glasses on there, but the solar filter is really nice. And we've actually been underground caving today at this location in Missouri, so we've gone all the way from underground, and now we're looking into space. Yeah, it's just started.
It started.
All right, so we're about halfway through the eclipse. It is noticeably colder on the ground here. Been recording with this camera, and then we've been using the little radio telescope here. I'm just aiming it based on the shadow in the center, keeping that centered on the sun. So move that away from the sun. And move it back towards the sun. There, we're centered.
Oh, sun's going down.
No,
Look at none of the colors.
Yeah.
More fun if the stars are coming out.
yeah.
Wow, there it is.
Oh, wow.
That pilot's having a good time.
Yeah.
Can't see anything.
The temperature gradient of
Wow.
the different ones as they come out.
Oh, here it's coming back.
Already? Oh my god.
Yeah.
One way to say that. So once we're done. Oh, fine.
So what did that look like from space? NOAA released some composite images from their GOES East weather satellite. You can really see the difference in this band 3 image that shows the very distinct shadow of totality and then the less distinct shadow for the partial eclipse surrounding it. So I didn't really have a solid plan for what to do with the tiny radio telescope. I basically just aimed it at the sun, recorded the sun's signal at about 1 gigahertz at 3 different points: before the eclipse, at about 50% moon coverage, and then at full eclipse. And this is what it looked like on the SDR system. Now, again, I didn't really do anything very scientific with this. I'm not actually doing any rigorous measurements, and I didn't continuously track the sun through the entire eclipse. I was manually tracking. This little particular dish has bad motors, so I can't get it to actually follow the sun. I just aimed it by hand, hit record on the SDR, and I think it kind of looks interesting, even if I don't quite know how to get real scientific data out of these recordings yet. Now, just as I did with the partial eclipse last year, I also recorded some ham bands, and I looked especially at the lowest ham band I could pick up with my SDR, and this is what it looked like before the eclipse. Pretty dead, not much activity. This is what it looked like during the eclipse. Quite a bit more activity, more Morse code operators, more interesting things happening. So the radio interference from the sun certainly decreases noticeably during the eclipse. All of the visible light is blocked, and all of the radio frequency interference is blocked, so you can pick up radio stations from much farther away.
5 by 252, 5 and 2 QSL.
All right, well, that 2024 total solar eclipse was a fantastic experience, and I am so glad that we took the time to drive down to see Totality. It was incredibly different between even 99% eclipse and 100% eclipse. Like, the sun is still shining fairly brightly at 90, 95, 99%. It still looks like daytime. Once the moon fully covers the sun, it is way different, way darker, way cooler, and you can actually look directly at the eclipse at that point with your naked eye. You don't have to use filters, you don't have to use the eclipse glasses, and it is amazing. So I am really, really glad we didn't do just 90%, 95%, whatever, because that kind of eclipse, a partial solar eclipse, yeah, you can look at it for a minute. It looks kind of neat, Pac-Man sun and all, but then you go back about your day. The total eclipse was an entire experience, and I would highly recommend it. Now, I know there isn't going to be another one in the US for quite a while. There's supposed to be one in Alaska in 2033. It's in a pretty remote part of Alaska, so there is technically a road to part of the area that's going to have that total eclipse in 2033, but it's one of those roads where you want to bring 4 spare tires, a spare windshield, and maybe a spare car, because it is not really meant for public use. A lot of little villages will be getting that eclipse. Maybe they'd appreciate some tourism, maybe they wouldn't, I don't know. Anyway, this was just a quick, kind of timely video that I wanted to get out because we were down there, we saw the eclipse, we thought it was amazing, and I wanted to share some of the things I did around the eclipse. The video, the half-assed amateur radio astronomy, and yeah, maybe not the most interesting, but I had fun with it. Thanks for watching, and we'll see you next time.